Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be upon you all and welcome to the channel. In this video we will discuss the generic class which is part of the Java Reflective API. But before we begin, Bismillah ar-Rahman ar-Rahim, Alhamdulillahi Rabbil Alameen. والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه ومن تبعهم بإحسان إلى يوم الدين وارض اللهم عنا معهم أجمعين اللهم آمين. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد. We begin in the name of Allah, the most merciful in this life and in the hereafter. We thank Him for all of His blessings that He has bestowed upon us, for they are innumerable. And we pray that we follow in the footsteps of Prophet Muhammad, peace be upon him, and his fellow companions. Amen. We also ask for prayers and blessings to be bestowed upon Prophet Muhammad, peace be upon him, and his family, as they were bestowed upon Prophet Ibrahim, peace be upon him, and his family. Now, as we have discussed before, the Java Reflective API allows for the manipulation of class metadata. Metadata refers to information about information or data about data. For example, this would be the data, its creator or its author, which is in this scenario myself, is metadata, just as an example. Now, since this API allows us to manipulate the runtime environment dynamically and programmatically, that would mean that the runtime environment relies on this class metadata, so it is incredibly important. Firstly, we will begin with class, then method class, then field class and constructor class and modifier class. We will leave the annotation class for the end, or the metadata regarding annotations, till the end, after we cover annotations at the end of the course, bi'idhnillah and God willing. Okay, so what is the first step here? Well, since this is an unknown class to us, let us open the class. And as you can see, it is a generic class, and particularly here it says use the invariance form if the class being modeled is unknown, so that is what we will use. Though we can use invariance, but since you are aware of the criteria needed for bivariance and it applies here, that is what we will rely upon. Okay, so firstly, what do we need to do? Since this is a data type, as you can see here, we will create an object name, but we will not rely on a constructor in this scenario. There are three techniques by which you can instantiate an object of class. So this is a specialized scenario or a specialized case that is specific to the generic class known as class. So what are the three techniques by which we can instantiate an object from class? Class object instantiation. I also prefer to call it class declaration as opposed to variable declaration. Here we are declaring an entire class. So this entire class will be declared, just as an example. Let us cover the first format, which I personally refer to as dot notation. This is my personal appellation for the technique. I do not know what is its official name. I believe it is called class syntax, but I prefer to use dot notation. This is my personal preference. So how can we create an object of class using dot notation? Well, let us start. Firstly, we will start with reference data types or reference classes because it is easier. Then I will show you a surprise for primitive data types. Class C1 is equal to, well, what is the class that I would like to access, or the class that I would like to access its metadata. Let us say in this scenario, I wish to access the metadata of the class string. So how would I do so? Well, I need to store the string class in this object, which is of data type class. That way I can access the metadata of the string class through this window. These methods allow access to the metadata of the class you pass on the right-hand side of the assignment operator. So as I mentioned, I wish to access the metadata of the string class, so I have to pass the string class in its entirety into this object of this data type. How would I do so? What is the name of the class? It is called string. Then dot, and as you can see here, dot class. Hence why I use the term dot notation. This means that the string class is being stored in this object of data type class. That way I can access the metadata of this class through this object via the member access operator, as you can see. For example, if I wish to know the name of the string class, I can use the getName method. If I wish to know the annotations used in the string class, I can use getAnnotation. If I wish to know which class loader loads this class, I can use getClassLoader, and we will cover that later, bi'idhnillah and God willing. If I would like to know the constructors available in the string class, I can use getConstructor. If I would like to know the fields present in the string class, I can use getField. If the string class has interfaces, I can get interfaces. I can get the methods. I can get the modifiers if it is public, private, or protected, and so on and so forth. If it is in a particular package, what is the package, and so on and so forth. So I can access the metadata of this class through this. Now you can say, well, I can simply go to the source and access it. That is correct. But if you would like to manipulate the metadata programmatically, this will prove meaningless because it will not help you in any manner. Okay. We will leave the metadata, the methods for the second technique. So the getName and so on and so forth, we will leave it for the second and third technique. For now, I simply would like to focus on this syntax here. Okay, so now I have access to the metadata of this class through the object of this data type. Perfect. This is Java library. So the string class is built in with the Java library. Am I able to use a customizable class or a user-defined class? Let us test it. Custom class. Let us create a class here. I will call it person. I will not call it I will just call it person. Class invariance. You can leave it like so if you would like, but simply to avoid the raw usage warning, I will just use the invariance. And the name is person, so let us say person in the default package, which is correct, dot class. So you can use a custom class that is in the default package. What if I create a class in a different package? Let us test this and see. So firstly, I will create a package, com.tutorial.java. I see what I did there. Okay. Delete this. The program thought I was creating a Java class. I probably chose create a class, did I not? Well, you guys were watching, so you probably answered that. I actually did not pay attention that I was creating a class instead of a package. There we go. Am I able to access teacher, which is in a different package, as you can see here? Class by variance C3, not the syntax ordinance from Metal Gear. Teacher.class. The only error we have is that we need to import it so that it is recognized in java.lang, which is the default package here. Or, as we have seen in a previous video, we can simply use this, which renders the importation statement redundant, but I will keep the importation statement to keep this short and concise. So I will simply create a bullet point here for reference data types. Am I able to apply that for primitive data types? That is the question, Horatio. Or was it Yorick? No, Yorick was the one, Yorick was the skull. Alas, poor Yorick, yeah. I knew him, Horatio. Like that matters if you knew him. You probably did not know him. Anyways. Class C4, again not affiliated with the explosive ordinance from Metal Gear. What if I wish to access the int class? Not the wrapper class, not integer, but int. Am I able to do so? Well, let us test it. Int dot. I am able to do so. Let us test it again with another primitive data type. Boolean, for example. So as you can see, you can use primitive data types through with the dot notation, with the dot notation. That means that everything in Java is localized within a class, because class loaders need a class to load onto memory before the program is executed. Nothing can be outside a class. Everything must be inside a class, as opposed to, for example, JavaScript. You do not need a class for JavaScript. Also C, you do not need a class, at least for the main method. Technically, classes do exist in C, technically, but they are not referred to as classes, mainly because C is not an object-oriented programming language. Anyways, that is a tale for another time. The only difference between primitive classes and reference classes would be the storage method. These are stored on the stack, while these are stored on the heap. But these are classes. Okay. Now let us move on to the second method, which I name after the name of the method that we will use. This is known as the for name technique, named after the for name method we will use. This for name method is used to invoke the class
loader, which is the system or application loader. We will cover that later. Worry not, God willing. This is the first loader that is invoked, and then it moves on to its parent, and that moves on to the main parent or the grandparent in this scenario, or this hierarchy. Okay, so let us read this method within this class. For name, like so. If I can find the actual, there we go. And use the rendered mode because it is easier to read. Firstly, it is a static method, so you need to call it with the name of the class, which is class. Secondly, it returns an object of class. Thirdly, it accepts an argument or a parameter called class name, which is a string. So it must be, the argument must be enclosed in double brackets. Double quotes, sorry, not brackets. Here is the return type. And as you can see here, it involves a class loader method, a class loader class, specifically get class loader. We will cover how to get a class loader later on, and I also have a lecture dedicated to the class loader itself. We will cover the 3 types and the function of each type, or rather the general function of the class loader, and then we will attribute or specialize the functions for each class loader. It will be a simplistic lecture, do not worry, bi'idhnillah, and God willing. Or at least I hope I can simplify it for you as best as I can. Now, as you can see, this method will be invoked for name 0. Let us check this and see what it is. And there we have it, called after security check for system loader, which is the first loader that is triggered. Access checks have been made. And as you can see, it is a native method. When we tackle the native keyword in the near or perhaps far future, I still have not decided yet, we will see what the native keyword refers to. But if you would like to know about it now briefly, when you see the word native, it refers to the native code, which is either C or C++. And I will leave it there for now as a temptation for later. Now this method, if we move on to the class loader class and look for a particular load, there we go. This is ultimately called through this, which is called through this. As you can see, it is called load class. So the class loader loads the class onto memory. We will talk about what resolve means later on, bi'idhnillah, God willing. Okay. Sorry, I was just reading the information here. Okay. So I will close this for now to avoid any distractions, because I tend to lose myself when I read. Okay. Oh, before I forget, an important matter here. See the example in this case? java.lang.thread. We will cover the thread class later on, bi'idhnillah, and God willing. But why did I emphasize this? Well, I would like to show you. Wait, does it say here? Associated with, no, I do not think it. The fully qualified name of the desired class, emphasis on fully. No need for the qualified name, but the fully part. And I will teach you how to read the Java documentation at the end of the course, bi'idhnillah, and God willing, because it is simple, so but it is unnecessary at the moment. I feel we should focus on the important portions of Java before we tackle that.
So emphasis on the term fully, and remember this for the upcoming example بإذن and God willing. Okay. So let us create, this would be C6 because I created C5 here. You can call the object names as you see fit. I thought I would use C followed by the iteration of the object. Is equal to class dot, because it is a static method. Ignore those two, we can cover them later on in the far future بإذن and God willing. So we will use this one, which returns a class and accepts a string argument. Okay. Let us take a class that we created here, which is person. So I will pass person. Remember, you pass it as a string. So you cannot use the dot notation because this is not a string, like so. Then you will see an error here because this method triggers or throws a certain exception. So you will see the error here. If you hover your cursor over it, you will see the error is an unhandled exception, which is this one. This is unhandled. We will cover exceptions after we finish the architectural portion of Java بإذن and God willing. So once we are done with the JRE, the JVM, the loader, the linker, the initializer, the bytecode verifier, once we finish all of these steps, we will cover exceptions and errors. You will see why I decided to leave them after the architectural portion. Oh yeah, we need to also cover threads. Threads and the stack memory, the heap memory, and the metaspace memory, and so on and so forth. Simply click on this and it will resolve it for you. If you are using Eclipse, if I recall correctly, this may not appear. It may appear or it may not, I do not remember. What I do remember is that you will see in the menu to resolve this error, you will see surround with try catch or try multi-catch. Just click on either or, whichever resolves the error. Probably the try multi-catch if it asks for a multi-catch, and it should resolve it for you بإذن. Now if I click on this, it will add the exception signature here. We do not care about that now. Okay. So this, because we do not want to focus on class loading now, think of this the same as this. The only difference is this triggers the loading of the person class. That is the only difference. Other than that, mechanically speaking, this is the same as this. Okay, so now we have stored the entirety of the person class in this so that we can access its metadata. Okay. Now, to show you the importance of this word and this example, we need to access the metadata of this class. We will not access all of it now. We will just access the name of the class, which is part of its metadata. So this is data. The name of the data, which is the class, is part of its metadata, the name. So how can I access the name of this class? Through this object and the member access operator. I wish to print the name, so C6 dot. And as you can see, get name returns a string, and from the name of the method or the method identifier, you can infer its functionality. You do not need to return to the class here. Okay, now let us print the name of this class. So now we are accessing metadata. Any moment now. The name is called person. That is the name of the class. What if I print the object itself of the class? What is printed? You will see. Class person. So here it simply types in the name, which is person only, the name of the class is person. But the object itself prints class person. So it prints this line to remind you that this is a class. You can check this from the toString method. Remember, when you print the object like so, it is as if you are saying toString, but this has been rendered redundant through updates of the higher versions of Java. But if you would like, we can check the toString method simply to see what it is printing or what it is designed to print. Aha, there we go. We will cover this later, and this is an example of what was it called again? The ternary operator. This is an example of a ternary operator. This is a nested ternary operator. I could probably create a lecture about nested ternary operators soon, bi'idhnillah and God willing. But if it is an interface, return interface plus the name, else return class and the name. So we will cover what this means and what this means either in this lecture or in the second half, because I feel somewhat fatigued since I have been recording videos consecutively today. So I feel slightly exhausted, so I may take a break and continue the lecture in another video, bi'ithnillah and God willing, possibly tomorrow. Okay. Now the reason I wanted to show you this is to emphasize what I highlighted earlier, which is this part. Let me revert to the rendered mode. Why I highlighted this part and the fully part. Okay. This is accessing a custom class in a different package. What if I wish to access a Java library class? I'll probably add this. Yeah. What if I wish to access a Java library class? Okay. Class C7 is equal to class for name string. Let us use string, the same as this one. Okay. And then we will type C7 dot get name. Let us see what happens. We have an error. Let me remove these from compilation so these two do not confuse you. We have an error. The class has not been found. So it could not locate the string class. That is odd because string is part of the Java library class. So why is it absent? Why did the class loader fail to locate this class? The answer is in this example and in this term. The fully qualified name. Here is what is annoying, at least from my perspective, about this method. If you wish to access a class from a particular package that is not the default package, as in it does not have a package. If a class is in the default package, it means it does not have a package. It is in the root folder immediately. If you wish to access a class in a package other than the default package, you must use the name of the package alongside the name of the class. You must. So we will add here must use package name alongside class name if class exists in a package other than default package, which is what we have been using thus far. If it is directly in the source file, the source code file, it is in the default package. Okay, so I know what the package of the string is, thankfully, so I will simply type java.lang, not lang.string. So let us test and see if this will function properly. So this should say string and this should say class string. Oh, it functioned wonderfully. But as you can see, it did not just say the class name by itself, it actually presented the package name as well. So, if you are using a class that is in a particular package, but it is a library, it is part of the library class, then you must use the package name. I am sorry, this should be default. Let us test this with teacher, just to cement the information, or the concept, I should say. Caps lock, different package. So teacher is in this package here. So let us see if we will have the error as we did with string. I am tired of writing. So this should be C7, this should be C8, like so. And here we will say C7 dot get name. Let us just test it initially and we can correct it later. Oh, I used person, my apologies. This should be teacher. We have an error, which is to be expected. We need to import it. Import it within the string format, that is. And as you can see, it worked beautifully, which is what we want. So let us test this as well. It should say class and then perfect. So this is incredibly important. It must be the fully qualified name, as in if it is in a package other than the default package, you must import it within the argument. You must write the name of the package alongside the name of the class. Okay, so I think what I will do is I will show you the third technique. So now we covered the dot notation. We covered the for name technique. I will show you the third technique, then I will end this video. Then in the next one, bi'idhnillah and God willing, we will access the metadata using common methods. We will not cover all of them, particularly since some of them are related to the method class or the field class or the modifier class or the constructor class. But we will cover the common ones or the important ones for the scope of this tutorial or this Java course. And we will cover this again in the second half. Do not worry, particularly with this format as well. So do not worry, we will return to get name once again. Bi'idhnillah and God willing. Okay, so the third method, or the third technique I should say, is also a method, and that is called getClass. Now remember, this is found in class. This, however, is found in the object class. We covered this, if you recall, when we tackled the object class and the implicit inheritance of any instantiated object. Any instantiated object
implicitly inherits the object class, so they all have access to this method if you recall. If you do not recall, I will show you quickly because this is not the scope of this video. Get class, and there you see it. Get class returns the class object of the object. So if the object is a student class, it will return class student. If the object is a person class, it will return class person, and so on and so forth. Okay, this means that we must instantiate an object of a particular class before instantiating an object of this class. And I will use the invariance here. What does that mean? Firstly, let us create an object from the person class, P1 is equal to new person, like so. This has now implicitly, and by implicitly I mean you do not need to explicitly say person extends object. This is redundant. It does so for you automatically. Remove redundant extends. It does so for you automatically. Oh, this is the wrong class. So now P1 has access to get class because it inherited everything from object class. Okay. So now we will create an object of class C9 is equal to P1 dot get class. So what happens here will be the following. Firstly, the class of P1 is returned. What is the name of this class? What is the class here of P1? It is person. Then once you do so, you store it in the object of class. So this is equal to this. We mentioned that this is also the same, but the difference is that it is used to invoke the class loader programmatically, as you can see here. I invoke the class loader using this method while I am coding here, which is why the reflective API is considered dangerous, because you can ruin your program inadvertently if you create a mistake. However, this is not different than this. This does not invoke anything. So you are probably asking then, what is the point of having this in addition to this style? I will show you in just a moment, and that is where we will end our lecture, bi'idhnillah and God willing. So let us test that this succeeded by accessing the name once more. And again, just to remind you, we will access name again in the second half of this lecture, so we can discuss the accessibility of the metadata fully in that lecture, bi'idhnillah and God willing. Perfect. And the same with this C9, just to see what will happen. Perfect. So this is with custom class default package. Okay, let us test this with a custom class from a different package, which is teacher in this case. So teacher, I believe I have the import statement up above, so I do not have to worry. Then we will say class C10. Why did I say T2? I was probably thinking of the Terminator 2 movie. Okay, then we will say C10.getName and C10
And I will remove these from compilation so that they do not print. It worked beautifully. We did not have any errors regarding the importation. So as you can see, it is exactly the same as this without any issues. This is the only method that has an issue, unfortunately. Well, I should not say unfortunately. It is because it invokes the class loader. So you have to inform the class loader where to find the class yourself. Instead of having the class loader search for it on your behalf, you have to inform him now. So the class loader here is taking a rest. You are helping the class loader. If you execute the program without helping the class loader, so without using this, the class loader will accomplish everything on its own. Okay, so this functions with custom class in a different package. Let us test it with a Java class. Java library class. Let us use string for simplicity. String s1 like so. Class not that one. s1 dot get class. And let us copy and paste. Why am I not using the Zahi way all the way? C11, C11, just to test it. And there we go. Beautiful. Okay. There is also another technique I would like to show you. So instead of s1.getClass, let us see if I can actually use the literal .getClass. So this is another method by which, or another technique you can use, is to simply use a literal and then .getClass. This literal is treated as an object or as an anonymous object. .getClass, like so. So I just wanted to show you that before I forget. So you can test with, let us test this and see. So you cannot use the string literal in this case. So you will have to, oops. There we go. Okay. Now we come to the final part of this lecture, because I feel I will shut down soon. So I would like to finish this lecture before I forget any important topic related to this. Let us see the differences between the dot notation and the getClass approach. There is an important aspect or an important difference you must remember. The dot notation is known as a static type, and we will explain it shortly, do not worry. And this is known as runtime type. You have seen that this is exactly the same as this. So I will copy it and paste it here for your reference, but I will remove it from compilation. This is the same as these two lines, albeit longer than only one line. So what is the difference between this and this? The answer is found in inheritance. So for you to actually visualize the difference between the runtime type and the static type, we need to view the difference through inheritance. So I will create a separate category here. Type differences. So the differences between static type and runtime type. Okay. So I will create what is it called? A child class or a subclass of person. We will use the same package. I do not need to use a different package. That was simply for demonstrative purposes. Student extends person, like so. We do not need to continue any further. Okay. So, again, we will see the static type again. What is the static type? Class C12 is equal to person dot class, whereas the runtime type will be as follows: person P2, yeah, persona 2, the game, new student. This is the polymorphism that we spoke of long ago, which is available due to inheritance. So the data type is of the parent class, but the constructor is the data type of the child class. And then it will be C13 is equal to P2 dot get class. Now I would like for you to pause the video, contemplate the matter, and then try to infer the answer through your ponderance. See if this will equal this. So how can we check that? Through the getName method. C12.getName, C13.getName. And again, we will explain the accessibility of the metadata in the second half of this lecture, bi'ithnillah and God willing. So we will cover getName once more. Okay, so this should probably be here. And this should probably be here. Okay. Let us run this. Person, but student in this scenario. So what happened here? At runtime, hence why the type is called runtime, at runtime, which data type is taken into consideration? The type of the constructor, not the type of the parent class. It is the data type of the constructor, which is in this case the subclass or the child class data type. Thus, because this object at runtime is considered to be of the student class, not the person class, thus the get class returns this instead of this. So when you access the name of the class of this object, it is student. However, static by static, normally when you hear dynamic, it refers to runtime. By static, it refers to compile time. This is known before runtime that it is the person class. It is explicitly stated through the dot notation. Here it may be confusing, and you keep wondering if it is this or this. But here, since it is explicitly stated, that is why it is known as a static type, because it is known during compilation or even before compilation, as opposed to this, which becomes known during runtime. So that is the difference. I wanted to highlight it so that you remember, even though they appear to be the same, be extremely careful with inheritance. And that is it with regards to this lecture. Again, I would like to remind you that we have not finished this lecture yet. There will be a second half later. I am simply tired from recording, so I would like to take a break, and I will continue bi'idhnillah and God willing tomorrow, inshallah. And we will cover the get name method. We will also, so we will cover C13 dot, we will cover get name, get, well, I do not wish to use get class loader and constructor yet, but we will cover a few common methods. I do not wish to scroll through everything to avoid wasting your time, but we will cover a lot bi'idhnillah and God willing, or at least I hope it will be enough for you. Do not be greedy. Anyways, I hope this lecture was helpful and beneficial to you all. Enjoy the rest of your day, everyone. Be safe, take care, and peace be upon you all. والسلام عليكم ورحمة الله وبركاته. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم، وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد.